I'm Cameron. I'm an iOS engineer at Instagram, and today I'm going to talk to you about our journey making Threads for iOS. I'll touch briefly on the inception of Threads, how we went about building it, some of the iOS challenges we faced along the way, and what we were able to accomplish in an unprecedented amount of time for an app of this scale. Late in 2022, planning for the new year, leadership started thinking about taking a swing at enabling more conversational flows within Instagram. We decided we were going to create a standalone app focused on conversations where creators and people would be able to easily find each other. And we were going to ship it in 6 months. Shipping a finished app to the App Store in 6 months is pretty aggressive. Creating a new brand is incredibly difficult, and with the time constraints, we thought it would give us our best shot to leverage everything Instagram currently does under the hood. Since we were using the existing Instagram codebase, it made sense to try and recruit engineers already familiar with that code. Instagram has a pretty high craft bar, and we wanted to maintain the same sense of familiarity and quality our users have come to love. We knew we couldn't ship an app that fell flat out of the gate. One of the folks tasked with the project had to start talking about it with other people, and calling it text app could only go so far. At the time, people looped in were told it was called Project 92 as a reference to the first SMS message that was sent in 1992. That became the code name and was kept pretty secretive as far as big company standards go. At this point, we'd recruited a team of people with different areas of expertise to try and help cobble this thing together. Now we just needed to build it. I mentioned earlier we decided to build on top of Instagram, and here's what that looked like. IG is deployed on top of Meta's massive server network, which gives us fast and stable distribution worldwide. Having most of that in place already was a critical reason we were able to ship so fast and scale as quickly as we did. The clients already have a ton of code set up to work with and parse these data models, which they then figure out how to render to the user. The natural point to us was to figure out how to use everything that existed except the UI. Even then, we knew we wanted this to look and feel like Instagram, so we tried reusing core existing views like the navigation elements, tab bars, and the action buttons underneath a post. We started by making a new entry point into the Instagram app, like going in the back door instead of the front, and removing a bunch of stuff we didn't need. This is also how the app's binary size kept shrinking after launch. We were working on decoupling, modularizing, and deleting unused code. Here we can see a very early version of the app with the Instagram tab bar, before and after we built any type of reply grouping logic. Tomer's post here was a reply to Tommy. Without the reply grouping, you can kind of see it being strictly chronological. The thread lines at this point were also just hard-coded to always show the loop, and the buttons were just for show, but you could see something. Navigating an old codebase was going about as well as we'd hoped. Generally painless, sometimes getting things for free, sometimes running into obstacles from people who built an app with completely different assumptions, that kind of thing. When you're building something from the ground up, you have first-hand knowledge and intimacy of every use case in the code, and can think about things kind of holistically. When you start working on code that has hundreds or thousands of different call sites, it's a bit harder to be fully confident what you're changing isn't going to break something else. When you face problems like that, you have to either surgically add on code that doesn't affect the other many uses, or find a way to make sure it works everywhere. Some code is pretty well tested, and some, well, not so much. Doing too much surgery adds a lot of technical debt over time, and one of the mindsets we'd adopted with Threads was that we wanted to leave as little a footprint on the Instagram codebase as we could. There's an old proverb that says nothing is as permanent as a temporary solution. We've all seen code supporting thousands or millions of users that started out as a lightning-fast prototype, never meant to see the light of day. Good ideas are contagious though, and demo code has a way of sticking around. We knew that cutting any corners now would cost us a lot of time in the long run. Saving a few minutes or hours today can mean trading off weeks or months of time in the future to correctly diagnose, debug, or build new features or use cases on top of. Since we already had buy-in to go build this thing and didn't need to worry about getting something working in a couple days, we wanted to build it in a way that could be scalable for future engineers finding their way into the Threads codebase. While we had an eye to the future, we were also careful not to over-engineer our code from the beginning. We built only functionality we needed and were careful and pragmatic about how we structured view models or API flows in a way that would hopefully be easy to step into and extend. Our investments into building a stable client infrastructure foundation here ended up being very instrumental in all of the features we've been able to build since launch. In the same vein, a favorite motto of mine comes from the US Navy SEALs. Slow is smooth, smooth is fast. Missteps or having to do something twice is so much costlier than doing something right the first time. Now, what right is might mean a few things depending on what the context of the situation is, but knowing what success looks like can often be the best path forward. Moving fast isn't very valuable if you're being reckless or having to slow down to fix what you've broken. As software engineers, the number one reason we write code is for other software engineers to maintain that code. Code that works and is understandable is infinitely more valuable than code that works and is clever. Instagram is primarily pretty plain Objective-C, with some Objective-C++, typically around video handling and logging. The day Threads launched, there was a public article wrongly claiming we wrote the app in React Native. But that was just because they'd seen that the library was still in our code. We hadn't yet had a chance to delete it. Meta has another language we call blocks that we use for universal experiences, or where centralizing some business logic can be important, like user authentication, reporting users, or the help center. We create most of our views programmatically, in code, instead of using nibs or storyboards or SwiftUI. Earlier this year, Instagram made a conscious effort to try and write new code using Swift, and we wanted to really advocate that with Threads. Instagram has started dabbling with SwiftUI, and there are a couple small instances in Threads, but it's not very substantial. This initial login screen was SwiftUI. Instagram and Meta overall generally leave specific implementations up to teams who are best equipped to make those kinds of tactical decisions. But there are trade-offs for things like compile time or cross-team dependencies that you need to be mindful of. Two common types of problems with established and large iOS codebases are ideas relating to type safety and nullability. Type safety, introspection, and reflection are ways that we have as software engineers to verify that an object is the type we think it is and safely perform operations on it. Nullability, on the other hand, is expecting an object and not getting one at all. Objective-C has some pretty great language features around working with objects that are nil and otherwise verifying and guarding against improper use cases. But over the years, as a codebase evolves and is worked on by many people or bots, some of these things can start slipping through the cracks if developers aren't careful with proper annotations. Swift solves both of these problems implicitly in how the language is structured. Those problems can still exist, but you have to go out of your way to make them happen. Most of the code we wrote dedicated to Threads was in Swift, but there was still a lot of touch points with older Objective-C code. And if that old code says it's passing an object to Swift and we don't get an object, we crash. On the plus side, we crash, and now we can solve the issue. In Objective-C, depending on what that code did, could just silently fail for days or weeks without notice. I don't want to say Swift is entirely responsible for the soundness of the Threads codebase or its low crash rate, but it definitely made it simpler for us to focus on what the code should do instead of how the code should do it. A lot of apps are just lists of something. Texts, emails, photos, stories, posts. Almost all of the lists in IG are powered by a library we created and open sourced nearly 7 years ago called IG ListKit. I won't go into too much detail here, but at a high level it allows us to pass around ordered collections of data, feed posts, DMs, reels, and allows the business logic for how to display a specific item to be encapsulated elsewhere. The real magic of the library is that it lets us know which items changed and how they changed, if they were inserted, moved, or deleted. After the list is changed, it lets the adapter and view know, and then we can re-render the list so we get to focus on the underlying data. In the IG feed, most of the underlying objects we pass around is a type called IG media. This object knows almost everything about the current state of a post, including things like who the author is, how many likes it has, the comments on it, and so on. When we render what to show to the user, IG media is mapped to a section controller, the pink here, that is treated as a single unit. That unit then has a collection view of smaller cells that each get rendered separately, that together become what we see here and identify as a feed post. The initial designs for Threads worked with this architecture as well. We had clearly delineated rows of content and would be working with the IG media object. The thread line spanned multiple rows in a lot of instances, but we figured we'd just make it work by having that be part of each subcell. Each separate horizontal unit, so here the header with the username and timestamp, and the replies, don't have a thread line, but the text, the image, the likes, and the interaction buttons would all have the thread line built into each separate row. Progress felt like it was moving steadily, and then we hit a couple roadblocks on some key features that we knew would take a lot of engineering effort to overcome. These all kind of happened around the same time, giving multiple work streams making progress at once, but they aren't strictly related, other than being connected to IG media. Those three problems were a redesign trying to optimize our information density, handling reposts, and some improvements to replies. Our initial designs made the app feel pretty empty once we'd gotten to a point where we could use it. We knew we needed to tighten things up and really focus on the text-first intention. In a conversational app, we felt that reposting content was important to the product experience, but there were no reposts in Instagram. In IG, every post is just a standalone post. If you want to repost, you just make the content new and maybe credit the author. If you want to reply to someone, you can kind of fake it by maybe screenshotting their content in your post and tagging them, or replying to a story in a private setting, but there was no actual notion of a reply. When we started tightening the views to rein in the negative space, we ran into the problem of a row being completely horizontally contained. The main problem here being that the profile picture now spanned multiple lines. You can also see that the text row, if only one line of text exists, no longer has a thread line, but needs one for multiple lines. Here's the problem in more clarity. On the left is the post as we want it to look. With only a single line of text, the profile picture spans two separate rows, and there is no thread line visible. Keep in mind, as we were building this, we were always keeping the option to ship quickly on the table. We didn't have time to do a full rewrite of our system, so we did what we could to make it work. We tried a handful of options and ended up on this as the solution. Put the profile picture on every cell. With some clever reuse in base cells, we were able to calculate how much of the profile picture should be shown on each row, and if we should offset it. We also ended up using this to support proper threadline end caps to get the nice rounding. Replies and reposts were a new use of IG Media. This object has a decade of implicit assumptions built into and around it, including that it would only ever exist once in a single surface. A post on your main IG feed can't be in two spots. When we show a reply to a thread, we want to show the original post to the user for context. So if you're scrolling and you end up with this post by the Backstreet Boys on the left in your feed, and then scroll some more and see this reply from Zuck to the Backstreet Boys, the top post now appears in more than one spot. None of our infrastructure was set up to support this. The same problem happens with reposts. A repost is kind of just the original post being broadcast again in another place by another user. We had to make a lot of fundamental changes to our underlying ordered data to make sure these worked fluidly. Because of the requirement for uniqueness in IG ListKit, we moved towards a container object that could be unique but reference the same underlying IG Media object at multiple spots. This is a rough idea of what this data wrapper looks like. A thread is a collection of thread items, and a thread item is some metadata around a base media object. The interactions between posts and replies that we ended up shipping with is actually a lot more complex than it looks on the surface. Some replies are collapsed, some can load inline, and others are only visible on the thread details page. Knowing we needed to be able to ship at a moment's notice, our milestones were tight iterations on what we were using every day. If our window to launch ever felt like it was right, we needed to be able to capitalize quickly. Now let's talk about our onboarding and launch. Anybody who's worked on a product knows that successfully onboarding users is the hardest part. We wanted to streamline that experience and make it really simple for Instagram users to get into threads. We used users' existing IG accounts for logging in as our name reservation system and hooked up some simple imports to pre-populate the information you'd like to bring over. We also made following all the same accounts you follow today easy to do if you wanted to. A couple weeks before we ended up launching, we revisited our onboarding process to make it more straightforward. Here's a before and after of two key screens in the sign-up flow. I know I mentioned doing the same thing multiple times isn't the best way to move forward, but adapting and pivoting based on new information and feedback can be just as valuable. To help broadcast to our users that Threads was a thing, we built a few features in Instagram to help fuel early adoption. The ticket here was just a fun Easter egg to try and leave a trail for people that might stumble onto it, and the joiner badge ended up being wildly successful to the point where there was enough demand for us to bring it back. Being iOS engineers, we felt it was important to have native support for sending an iMessage. This didn't work out of the box for us, but we filed a radar after having what we thought was most of the proper tags populated, and were able to work with Apple engineers on figuring out how to get us up and running. When we were ready to go, Zuck made the first official post, and we hid everything we'd been posting before then from the public. We had dozens of folks involved in engaging with thousands of creators to try and start seeding the platform with desirable content before we open more broadly. Just to kind of look back on the journey, our first iOS Threads commit was in late January. We submit the version that would go live to the App Store in late June, exactly 150 days later. In that time, 30% of the Swift code written at Meta was in the Threads codebase. And that crash rate is not a typo. Most of our crashes were from iOS 17 changes that we couldn't easily accommodate. At Meta, we use a build system we created called Buck that handles the building, caching, and distribution of compiled code artifacts to try and minimize the time developers spend building their apps. Proper iOS 17 support came the following week internally, which allowed us to fix most of the crashes that existed for the next app update. By the end of the 5th day, we'd hit 100 million users, which was by far the fastest of any app ever. While a lot of products don't get the benefit of a pre-existing network, it was still a monumental feat and a whirlwind of emotions over the first week. Not having to build infrastructure that could scale to billions of network requests was one of the countless things that helped us get out the door so quickly. That's most of the story of the birth of Threads. Meta likes to say the journey is only 1% done, and the Threads unveiling was truly just the beginning. We wanted to ship a minimum lovable product, something we could try and use to find product market fit, and getting it into the hands of users was the best way for them to validate what we should be building. With such a tight timeline, we had to ruthlessly prioritize what to build every single day. Once we launched, we got the benefit of millions of users telling us what they wanted to use on the platform, which is a great way to know you're on the right track. Since then, we've been able to launch quite a few improvements. When this talk goes live, Threads will be just 4 months old. But that stable base we spent time building has allowed us to keep moving quickly and focus on building features, not worrying too much about the foundation. A couple weeks after launch, we shipped the chronological following feed, post translations, activity page filtering, and the follow all button. That was followed up quickly with integrated sharing with Instagram DMs, a way to view all the posts you've liked, custom alt text for photo and video production and consumption, enhanced voiceover and screen reader support, account follower sorting, and a mention button on profiles. In a move towards Fediverse integration, we added Realme support in Threads profiles. Hearing feedback from the Threads community, we brought reposts to the following feed and added a consolidated entry point for viewing the reposts from a user on their profile. The same week, we launched a version of Threads on web that you could just log into and use like the mobile apps, not just read content anonymously. We built and shipped search for actual topics, not just users, and are working on increasing the number of languages supported. We added notifications for specific threads so you can follow along with a conversation on a post that interests you. We built out multiple account support, including fast account switching with the same intuitive gestures you find on Instagram. And that's just the features that made the headlines. Every week we've been shipping love and bringing little improvements, stability fixes, efficiency wins, or more delight to dozens of parts of the app that millions of users see every day. From the time I recorded this to when you're watching it now, there'll be a handful of features launched that people will be stoked to see. In the coming weeks and months, we'll launch more exciting things, and I hope we can keep growing together. If you want more details on what I talked about today, make sure to check out the blog post. And if you have ideas or feedback, you can find us on Threads. Thanks for watching.